Okay, so scientific notation. Why do you have to learn this? Well, there's several different fields out there that work with really big numbers of things. Like if you're in the science world, let's just look at the weight of the Earth. How could you express that in pounds? The number would be huge. What's the distance between the sun to the Earth? What's the circumference of the Earth in feet? Just numbers can get really big, and usually you can choose to make it a better unit of measurement to make it more manageable. But sometimes we don't always have that option when we're trying to compare things. We need to have it to be in the same type of unit rather than comparing uh, millimeters to miles. Maybe we want both of them in miles. It's the basic idea of that you would take really big numbers, like let's take a look at 21, very small number, and you put a zero on there, and so it becomes 210. Put another zero on there, it becomes 2,100, 21,000, 210,000, 2,100,000, and we've only put on 5 zeros. But what if we put zeros on here all the way to the end of the screen? It would make it a very, very large number. And this is nothing. This is still kids play. So a lot of the large numbers that are out there. And I mean, look, it's taken me forever to write these zeros for the most part. If I was on paper, it'd be a little quicker, but not by much. Um, and now if we put the commas in here so it's easier for us to understand it, well, let's see. Here's the hundreds, thousands. Right here's the millions, billions, trillions. Does anybody else know what comes after trillions? You can look that up if you want, but I mean, it's just those are numbers that you're not going to be using on a regular basis. And so when we look at scientific notation, we want to come up with a method to write this number quick, efficiently, and save us time. I'll give you one other example of a number. It's called a Google. I was looking through on Khan Academy videos. Excuse me, that should be an O right there. And he mentioned there's a Google, and what that is I didn't misspell it. We're not talking about Google. That's like, google.com. We're talking about a Google, Googol. It's the number one with 100 zeros after it. 100 zeros. Now, can you imagine how long it would take to write 100 zeros? And then imagine how long it would take you to count up the zeros to make sure you had 100, or if you lost count while you were writing them. I had my class do that today, and it took them about a minute for the fastest ones. And I mean, hey, they might have made a mistake. And we're talking about three-fourths of the rest of the class were still working after a minute. So it would take you over a minute to write a Google. Um, so how does scientific notation work? Well, it's got this basic template. We're going to take some number, and if it's bigger than 9, basically we're going to put a decimal after it, and we're going to times it by 10 to some exponent. So it could look like this, 2.12 times 10 to the 8th power. This is scientific notation. If you're going to have a decimal in this front number, you're going to have to put the decimal after the very first number, the first number that's not 0. And then all the other non-zero numbers, you just trail along after it. So it could be like 2.3 times 10 to the ninth, 9.67 times 10 to the eighth. How about 2.105 times 10 to the seventh? Now, right now, the only thing that you should really be focusing on is the placement of that decimal. Okay, let me get a different um, pen so that way it makes it a little bit easier to see. You should be looking at the placement of the decimal. It's always after the first number that's not 0. And then the other thing is that you're always going to be multiplying it by 10, and then it's going to be to some type of exponent. So here's the exponent. So let's take a look at this. Which ones are proper notation? Let's see. The decimal is after the very first number. Okay, that's good. We've got the multiplication sign. That's good. It's multiplying it by 10, and it's to an exponent. So yes, that is a proper scientific notation. This one, well, technically, this is my issue. 0 is not a good number to put the decimal after. It should be like 6.1. We put it after the first number, it's not 0, 6.1. So that's my issue with number 2. This is not a good proper scientific notation. And then it's times 10 to, whatever exponent you have. But that's the issue. It's got to be a non-zero number, and then the decimal comes. And see, there's my issue right there. It should be 2.67. We had the decimal after the 6. It should be before because it's after the very first number. The times 10 to the 10th power, that's fine, but the decimal is what made us say that this was not a good example initially. Here, where's the decimal at? It's right there, and it's invisible. I didn't even write it. So if you don't see the decimal, it's at the end. And so, uh, no, this is not a good example. It should be 1 times 10 to the 13th, or it should be 1.0 times 10 to the 13th. That's the issue that we have there. The decimal's in the wrong spot. Decimals in the placement, if you want to call it scientific notation, it's got to be after the very first number. So, hey, look, what do you know? We finally found another example that's correct, and then it's times 10 to the 8th power. So this is a good example, or yes, it's a proper form of scientific notation. So let's take a look about how we use scientific notation for large numbers. Now, my other videos, we'll start talking about how we're going to use it for really small, microscopic numbers. But today we're just focusing on large numbers. This number right here, really, I don't think we need to use scientific notation for. It's just, let's see, 5,900,000,000. That's the size of that number. We can easily write this, but I don't want to use an example where it has like, 37 zeros on there. That's just too cumbersome to try and teach with. So we'll use 5,900,000,000. How do we write this in scientific notation? Well, first off, insert the decimal after the first digit that's not zero. So let's see, here's the 5. So I'm going to write 5 and then put my decimal. And here's the second step. Copy the rest of the numbers except the zeros at the end. And so if you were looking at the original number up here, you'd say, well, here's a 5, here's 9, and then everything else is zeros. So in your mind, you're kind of boxing that out. Now, what I did here was I typed out the number again, and I made the non-zero numbers in red. So you'd go, 5.9, and then the second part of um, the third step would be just times it by 10, because we don't need to write all of these zeros. This is what scientific notation does away with. And now we've got to figure out, how do we know what exponent to put here? Well, it's a trick of the powers of 10. Um, if I said 5.9 times 10, if you type that in a calculator, you get 59. If I say 5.9 times 100, you would actually get 590. If I said 5.9 times 1,000, you'd get 5,900. You can put this in your calculators and check it out. But then what we can do is we can take these powers of 10 and write them as an exponent. Well, 1,000 is the same as 10 to the third, and 100 is the same as 10 to the second, and 10 is the same as 10 to the first. So let's stop and think about this. How many times does this decimal move when I times it by 10 to the first? 5.9 becomes 59. So the decimal's sitting on the other side of the 9. So it moved over one time, and the exponent told us how many times to move it. So now we're going to move the decimal over 2 times. So it would be like 1, 2, and I'd have to put a 0 here. It's a place value, so 5.9 becomes 590. And if we times it by 10 to the third power, it's going to move it over 1, 2, 3, and we'd have 2 zeros would be putting on here as place values. So 1, 2, 3, 5,900. So do you understand how this is starting to work? Really, the exponents is the number of spaces the decimals have to move. Well, let's clear that off. Let's see. We have 5.9 times 10 to the something power. Let's see. The decimal moves from here all the way back here to right after the 5. So 3 spots, 6 spots, 7 spots. I'm sorry, 3, 6, 9 spots. Can't count there. So that's our answer, 5.9 times 10 to the ninth. And that's the last step. You count the number of spaces you move the decimal to figure out the tens exponent. So let's try a different example. 3,350,000. Very first thing, insert the decimal after the first number that's not 0. So there's my first number is not 0. Let's put a 3 there. Then copy the rest of the numbers except for all of the zeros that are on the end. So I got to pull down that 3 and the 5. Step 3, times it by 10. And now we've got to figure out how many places this decimal that's sitting down here is going to be moved. That's 3 spots, 6 spots, and we would wind up right there. So it's 10 to the 6th power. That exponent tells us how many times or how many places the decimal is going to move. This one, very similar. Let's see. Put a decimal after the first number. It's not 0. Times it by 10. And remember, we write down the rest of the numbers that are not 0. All of these zeros hanging at the end, basically, we're just saying that's the whole point of scientific notation. It's a way for us to skip that cumbersome process. So 1.117 times 10 to the, let's see, that's 3. Here's 3 more spots, so that gets us up to 6. Here's 3 more spots, that gets us up to 9. And then one more, that's 10 spots, we got to move it. So it becomes 1.17 times 10 to the 10th power. And I want to do one other thing. Let me pull the calculator up for us. And what I'm going to do is I'm going to type in 1.117. So there we go, it's on the calculator. Times 10 to the 10th power. And hit enter. And if you notice right here, what's happening is it's 1.117 E10. This basically means they're trying to tell you, you know what, this number is so large we need to flip over to scientific notation. So it's 1.117 times 10 to the 10th. So when you see this little e, it's trying to tell you in scientific notation. When we flip back to this one right here, because this number is small enough, let's type in 3.35 times 10 to the 6th power. There we go, 3.35 times 10 to the 6th. We should get 3,350,000. Yeah, 3,350,000. Another way to look at this too, before we go any further, is this is not black magic. It's not anything magical or mystical. It's this. Another way that we could write this, but it's not scientific notation, is 3.35 times 1 with 6 zeros after it, because 10 to the 6th, it would have 6 zeros after that 1. So 3.35 times 1 million. Let's try that. 3.35 times 1 million. 1, 2, 3, 4, 5, 6. Same answer. Um, it's this powers of 10, and 10 to the 6th, it really is 1 million. When we're looking at this powers of 10s, you take the exponent and you go, ooh, put a 1 there, and that's how many zeros are after it. Let's go through a couple of more real fast. What would we do with something like this? This is a huge number here. So what's the very first number? It's not 0. It's this 4 right here. So we say 4 point, and now I go and collect all of my numbers that are not 0. If I trap some zeros in between there, see, like from here on, it's all zeros. If I trap some numbers in between that are not 0, I still pull them straight down. And now I say, okay, I left off all the zeros at the end, times it by 10, and now we just count up how many. Let's see, here's 3. 3 more makes it 6. Now we're at 9. I've got to move this thing 12 times, so it's times 10 to the 12th power. You can pause the video real quick and then solve these and see how you do. And there we go. You get all of your numbers that are not 0. Anything that's a bunch of zeros, you just let hang off the end. Put your decimal off the first one, times it by 10 to whichever power.